Hello again. Welcome to another lesson in geometry. Today we are covering section 4.3, triangle congruence by angle, side, angle, and angle, angle, side. All right, so we have some vocabulary here. Cross out the figures that are not triangles. So the first one's not a triangle, third one, and the fifth one. Okay, so a triangle is a polygon with three sides, and that's why the second and the fourth one were triangles. And a triangle with a right angle is called a right triangle. Remember, an obtuse triangle has one angle larger than 90, and a scalene triangle is a triangle that has no sides that are congruent. Okay. All right. Corresponding. Corresponding is an adjective. Okay. Other forms are correspond as a verb and correspondence as a noun. So corresponding describes sides of a triangle for us. So we have corresponding sides, and the corresponding means they're in the same position and the same length. Okay, so same position in the triangle. So definition, corresponding means similar in position, purpose, or form. And our math usage here is congruent figures have corresponding parts. All right, so draw a line from each part of triangle ABC in column A to the corresponding part of triangle XYZ in column B. All right, so BC has 3 marks on it, and so does YZ. So BC and YZ are the same. Angle A comes between the one with 1 mark and 2 marks, so angle X is going to be the same. AB has a 1 mark on it, so YX is the same, or XY. And angle C comes between the 2 marks and the 3 marks, so that's angle Z. Okay. And AC has 2 marks on it, so that's the same as XZ. And then B and Y are going to be the same. So these are the corresponding parts of our triangle. All right, let's flip it over and learn about our 2 new postulates, angle, side, angle, and angle, angle, side. Okay, on our second page, we have postulate 4-3, but we're just going to use angle, side, angle postulate, or even shorter, the ASA postulate. Okay. All right, so the angle, side, angle postulate says if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, then the 2 triangles are congruent. So it's very similar to the SAS, but in that case we had 2 sides with a congruent, the included angle, and this time we have 2 angles with a included side. All right, so in this first diagram, if A is congruent to D, so they're marked with this part, and AC is congruent to DF, so AC and DF are congruent, and C and F are congruent, so we're marked with these. All right, then we can tell that triangle ABC and triangle DEF are congruent, and that's because they have 2 pairs of congruent angles, and the side included between them is congruent in both of them. All right, so explain how ASA postulate is different from SAS postulate. I would say something like this. The ASA postulate uses 2 pairs of congruent angles with included congruent sides. And the SAS uses 2 pairs of congruent sides with included congruent angle. So one of them uses 2 angles, one of them uses 2 sides. Congruent angle. Okay? All right. So using angle, side, angle. So which 2 triangles are congruent by angle, side, angle, and we need to explain. So we have some steps here to help us with this. So first off, we want to name the triangle. So we're going to list the vertices in corresponding order, which is very important. Okay. And then list the vertex with the 1 arc first, the vertex with the 2 arcs second, and the vertex with the 3 arcs, which isn't drawn. So the third vertex here, third. Okay. But we don't actually know if the one without them are congruent. Okay. All right. So let's see. This one would be triangle, 1 arc is G, 2 arcs is H, and then the third one is O. And this one's going to be triangle The 1 mark is I, the 2 marks is N, and the no marks are F. And this is triangle. The 1 mark was C, the 2 marks were A, and the no marks were T. All right, so in this, angle G, which is in first position of the triangle, should be congruent to angle I and angle C. And that's because all of them have 1 mark. Okay, so angle I and angle C. And then angle H, which is in the second position in the way we named our triangle, has 2 marks, and it's congruent to N and A because those are the ones with 2 marks in the picture also. So N and A. And then HG is congruent to, let's see, so that's 1 mark, so NF. And let's see, the 1 mark here would be AC. Okay. All right, 2 congruent sides that are included between the congruent angles are, let's see, I'm going to have to go with HG and CA. That's the side that comes between the angles, whereas this side in the middle one does not come between the 2 angles. So we're going to have to go with HG and AC or CA. Okay, so write a congruent statement and justify your reasoning. So I know that the first and third triangles are congruent. So triangle GHO is going to be congruent to triangle CAT by the SAS. Oh, I'm not sorry, not SAS, the ASA postulate, because they have two sets of congruent angles with the included sides congruent. Okay, so that one in the middle did not have the included side congruent. It really needed that side to be right there, NI to be the congruent side. All right, let's flip it over and look at page 3. Okay, on page 3 we have problem number 2. Writing a proof using angle side angle. So given that CAB and DAE are congruent, these are our vertical angles in the middle here of the diagram. So CAB and DAE. And then that BA and EA are congruent. So BA and EA are congruent. And that B and E are right angles. We want to prove that the left triangle over here is congruent to the right triangle over there. Okay, so the one on the left side and the one on the right side. So to complete the flow chart to prove those 2 triangles are the same, so in our flow chart we have the 3 givens. So we'll go ahead and fill those in again. And the first given we have B and E are right angles. And the second one we have segment BA is congruent to segment EA. So side BA and EA are the same. And in the third one, we have CAB is congruent to angle DAE. Okay? All right, so we know that all right angles are congruent. So we can say B and E are congruent. So we could go back and remark our diagram with double marks here, okay, to show that they're the same. All right, so we're supposed to be able to use angle side angle. So angle side angle is 2 angles with the included sides. Let's see if we have that. Notice we're taking 3 parts to make 1 in our flow proof, and that's because each part will represent one of the letters in angle side angle. So over here we have one set of angles that are congruent, corresponding angles. And over here we have another set of corresponding angles that are congruent. And this set of sides here are the included sides between them. So that's why we have angle side angle. So triangle ABC and triangle AED, make sure I get my corresponding angles in the same spot, are congruent by angle side angle. And here it is right here showing it. So it takes all 3 of these things to prove angle side angle. All right. Now our last theorem for today, and this one's a theorem because we'll have to prove it. So angle side theorem says if two angles in a non-included side of one triangle are congruent to two angles and the corresponding non-included side of another triangle, then the two triangles are congruent. Now that corresponding non-included side is important. We need to make sure we get the side in the same place in both. Okay, so angle A and D are congruent here, and angles B and E are congruent. And then we have congruent corresponding sides that's not in between. That's okay. So in this case, we have the one that's touching the one angle mark, and over here we have the one touching the one angle mark. Okay. If we had used F and E in our second one, it wouldn't work for us because that's touching the two angle mark, and then in the first triangle, the one was touching the one angle mark. Okay. So in this case, angle ABC and DEF are congruent to each other by the angle side theorem. And the non-included congruent sides of ABC and DEF are AC. That's the one that had the one mark. And DF, that's the one that had the one mark. And notice that they are the corresponding sides because they both touch the angle with the one mark. Okay. All right, write a proof using angle side. So given that angle S and angle Q are congruent, so that's why they have the red marks here, and that RP, this segment, bisects SRO, so it bisects this big angle SRO. We want to prove that the left triangle SRP is congruent to the right triangle QRP. So how do you know which angles in the diagram are corresponding angles? All right. So you should have something like this. They have the same number of arcs on them. Okay. So when we're looking at angles in a triangle, we want to see who has the same marks to see the number of arcs, who has the same number, so we can see which are corresponding to each other. All right, so let's complete our proof here. We have a two-column proof this time. So our statements are on the left and our reasons are on the right, unlike the flow proof where our reasons were above the statements. All right, so we have angle S and angle Q by the given are congruent. And we have another thing from the given, RP bisects angle SRO. All right, so we're trying to use angle side. Now, bisects is a very special word. It means it cut that big angle, SRO, in half exactly. So SRP, the one over here, is going to be congruent to QRP, the one over here. So we can put two marks on here. Remember, we already have the one mark there. So SRP is going to be congruent to angle QRP, and that's just the definition of a bisector. If something bisects an angle, it splits it into two equal parts. Oops, that was QRP. Last one looked like an R again. All right, and we also know that RP is congruent to RP. And that's a side that's in both of the triangles, and we'll use the reflexive property to show that. Okay, so RP is RP, so that means that since this side right here is in both triangles and it touches the two marked angle in both of them, then it's a corresponding side. All right, so now I have all the parts I need here. I have an angle, I have a second angle, and I have a pair of corresponding congruent sides that are not included. Okay, so that's angle side. So I can say triangles SRP and triangle QRP are congruent by angle side. So we have all three of the pieces right here. Okay. All right, flip it over. Let's take a look at the last page. Problem 4 on our last page, determine whether these triangles are congruent. And we want to check is triangle PAR and SIR congruent. All right, so there are some congruent marks already on our triangles. We have angle A and angle I are marked congruent. Those are the little arcs on there to show in the picture. And we have PR and SR as sides of the triangle that are marked congruent. Are there any other corresponding parts that are congruent? And how do you know? So it's basically saying, oh, is there another part of the triangles that are congruent even though they're not marked? And this is yes. Angle PRA should be congruent to angle SRI, and that's because they are vertical angles, and vertical angles are always congruent. Okay, so RPAR and SRI congruent, and this should be yes. Okay, let's see if we can tell why. So let's mark our vertical angles in here. So 2 marks and 2 marks. So we have, for angles, an angle with 1 mark, an angle with 2 marks, and then a non-included side. And then for the other triangle, we have an angle with 1 mark, an angle with 2 marks, and then comes the non-included side that's congruent. So we have corresponding parts that go in the form of angle, angle, side. All right, so as always, pause the video before doing the lesson or listening to the lesson check so you can try it yourself. All right, so welcome back. So reasoning here, suppose angle E and angle I are congruent, and FE and GI, the sides, are congruent. What else must you know in order to prove that the two triangles are congruent by angle, side, angle? And then what else would you need to know to prove the two triangles are congruent by angle, angle, side? So we have some way to walk us through this here. So first we're going to label the diagram correctly. So we know that angle E and angle I are congruent. So I need E to be over here and I to be over there where the 1 marked angles are. And we know that FE and GI, so FE is here and GI are congruent, okay? And this is supposed to be triangle FDE, so we put D in the missing spot. And this is supposed to be triangle GHI, so we'll put H in its missing spot. All right, so to prove the triangle is congruent by angle, side, angle, what do we need? Okay, well, we need 2 pairs of congruent angles and a pair of, and we need the included side to be congruent. So 2 pairs of congruent angles and the pair of congruent side, 1 pair of included congruent sides. Okay. All right, so to prove the triangle is congruent by angle, angle S, what do we need? Okay. Well, we need 2 pairs of congruent angles, same as before, and 1 pair of corresponding non-included sides, congruent sides. Okay, so it's a little bit different. In angle, side, angle, we want the side to be between the 2 angles, and in angle, angle, side, we want the sides to be corresponding, but not between the 2 angles. So if you want to use angle SA or use ASA to prove congruence, then we need to have angles, let's see, F and G to be congruent. So to do angle, side, angle, we need the angles that are between the sides. So we would have to mark this one and this one, so that the sides between the 2 angles. Okay. If you want to prove angle, angle, side, okay, what else would we need? Well, we already have the side, we just need a different angle. And we don't want the angle that makes that side be included, so we're going to have to use this angle up here. Okay, so that's going to be angles D and H. And we lost our D and H here. Okay, so in this case, we have angle with 2 marks, angle with 1 mark, and then comes the side with 1 mark. And here we have angle with 2 marks, angle with 1 mark, and then the side with 1 mark. All right. Okay, so that concludes our notes for today. And you should have a good idea about what included and non-included side means and how that goes with angle, side, angle, and angle, angle, side. And then, of course, what corresponding sides are. And then how well can you use angle, side, angle, and angle, angle, side. So that means, can you use them correctly in a proof? Okay, and we want to be over here by the end of our lesson next time in class. All right, I'll see you then.